Welcome back, my students. Now, today we are going to talk about the acceleration of this body undergoing periodic motion. Now, for you to get the acceleration of this body, you should have something in mind. And what is that? You notice that this body is moving in a circular form, and there is a force keeping this body in that circular form. What is that force? That force is called a centripetal force, okay? The force required of this body to move in a circular form. So because of that centripetal force, that will result in centripetal acceleration. We notice that when this body is moving in a circular form, the acceleration of the body is directed toward the fixed point because of the centripetal, okay? There is an inward acceleration. And that acceleration is what I represent with this AC, okay? There is always an acceleration, centripetal acceleration, when the body moves from here to here in a circular form, okay? Remember, we consider the body from this point to this point. So there is a centripetal force here, centripetal acceleration due to centripetal force. So because of centripetal force, which is equal to what? mv square over r, that will result centripetal acceleration. Now, acceleration is a vector quantity. We need to resolve this acceleration into components. To resolve it, we are going to have this acceleration in side of what? Y, and also acceleration of what? X, okay? Now, because our motion is considered this way, we are going to bring this diagram again. If you bring it out, to consider this diagram in terms of what? Acceleration. We have theta here. So this is for AX. Remember, we consider on the horizontal axis. This one is for what? AC. Okay? To resolve this thing, we have this moving in this way. We also have this, okay? So under that, we are going to say that what? Cos of what? Theta, because this is adjacent again and hypotenuse. Cos of theta is adjacent, which is AX, over hypotenuse, which is what? AC, okay? So AX here, the acceleration along that horizontal is given as what? AC cos of what? Theta, okay? Now, remember that AX here is equal to the centripetal acceleration is given as what? V square over R, okay? So this is formula for the centripetal acceleration. So if I put it here, I am going to get V square over what? R. We now have cos of what? Theta, okay? Now, if you look at this formula, you see that what? I want to relate acceleration with displacement, because there is something that happens between acceleration and displacement. The acceleration of this body undergoing periodic motion is directly proportional to its displacement, okay? So because of that relationship between them, I am going to relate both of them, okay? So if I'm relating both of them, I am going to have that AX, that is the acceleration, is equal to V square over R. So this cos theta, remember, in terms of displacement, cos theta is given as what? X over R, okay? So we are going to multiply, because this is what? V square over R, which is this, multiplying cos theta. And cos theta is equal to what? X over what? R, okay? So therefore, AS is equal to V square X over R times R is what? R square. So which implies that AS, that acceleration along that S axis, is given as what? V square over R square X, okay? Now, if you look at this, you are going to see that what? There is angular velocity, angular frequency, okay? To bring in this angular frequency, we know that what? The relationship between this angular velocity and the linear velocity in terms of radius is what? V is equal to what? WR. So if I have formula like this, to get this particular one, I am going to divide by R. If I divide here by R, divide here by R, this cancel this. W is equal to what? V over what? R, okay? So because of that, any place I see V over what R, I am going to call it what W. That is what this formula is all about. Now, because of that, what am I seeing here? AX is equal to what? Look at V. V over R. This is V and R all square because both of them are having squares multiplied by what? S. So that I will be able to put that W. So what is W? V over R. V over R means what? W. So this V over R here stands for what? W. There is what? Square here. We have X. Now, from this definition, the acceleration is directly proportional to what? Displacement, but in opposite direction. Meaning that what? When we have this, we are going to have W square into, this is positive now, and this one is going to be on the negative direction, okay? So in that case, the acceleration AX is equal to, if this multiply this, we are going to have minus W square X. So this is the formula for the acceleration of the body moving in a periodic what? Form, which I can also call AX is equal to what? Okay, AS, when this cross to the other side, we are going to have plus what? W square S equal to, what is here now is what? 0. I took everything here to the other side. We have this. So in advanced level, this acceleration is what? Displacement dot dot plus what? W square X equal to what? 0. We can use this, but for secondary school level, we can also what? Use this. This is the most important part of what? For people preparing for WAEC and what? JAMB. But for advanced level, which is university level, we can also consider it this way. So now the point I have made here is what? There is an acceleration which is directed toward the fixed point here, okay? Moving inward due to the centripetal what? Force, okay? And because of that, we'll be able to find the acceleration on the what? Horizontal force. See you in the next video, which is what? The period and the frequency of the motion, okay?